This is the exam review for Module 3, so make sure you have your review printed and in front of you. If you will look at the first section, it's on rational expressions and functions, looking at domain restriction. So in problem 1, we're given a function, f of x equals 3x plus 1 over 2x squared plus x minus 6. And we are asked to find what x cannot be equal to, which another word for that is the domain restriction, the things that x can't be because it would cause a 0 in the denominator. So if you'll remember, it doesn't matter about the variable in the numerator. All we care about is the variable in the denominator. So we take that denominator, 2x squared plus x minus 6, we set it equal to 0, and we're going to solve for x by using, in this case, the 0 factor property. So we're going to have to factor it to see what x would be that would cause division by 0. This is a long process trinomial, so I multiply. I want factors of negative 12 that combine to make positive 1. Those are positive 4 and negative 3. So we bring down 2x squared. Break down that x into these two pieces, so plus 4x minus 3x, bring down the last one. And now, because I have 4 terms, we are going to group. That minus sign in between causes me to have to make a correction on the last term. And now I factor out the GCF of the first binomial, which is 2x, and I'm left with x plus 2. Bring down your minus sign, factor out the GCF here, which is a 3, and we're also left with x plus 2. So my two factors are x plus 2 times 2x minus 3 equals 0. So we had it equal to 0. We just factored. Now the P stands for setting each factor equal to 0 and solving. So x plus 2 equals 0, or 2x minus 3 equals 0. I solve here and I get x cannot be negative 2, because if it was negative 2, you would end up with a 0 in that denominator. Here, I'm going to add a 3 and then divide by 2, and I get x also cannot be 3/2. So those are the things that x can't be. The things that x can be is what we call the domain, and you write it what we call set builder notation. It's written like this: the set, just a squiggly brace, of all x such that x is not equal to, and then you rewrite the restriction, negative 2 or 3/2, meaning x is everything except that. So it's sort of two different ways of writing the same idea. This is what x can't be. This is what x can be. All right, looking at example 2, it says to write in lowest terms. What you want to remember on all of these rational expression problems is that you have to factor first before you can cross cancel. So I'm going to factor my numerator. It's a short process factoring because of the 1. I need factors of negative 14 that combine to make negative 5, negative 7, and positive 2. So that's y minus 7, y plus 2 over, again, the denominator is a short process, so I need factors of negative 2 that add up to positive 1, and that is going to be a y plus 2 times y minus 1. Now that everything is factored, I can cross-cancel entire factors. So I can cross-cancel y plus 2 and y plus 2, and what's left is y minus 7 over y minus 1. All right, looking at number 3, we're going to do the same thing. We're going to factor before we cross cancel. So my numerator is difference of two squares, so it's x plus y, x minus y, over the denominator is y minus x. Now notice, the numerator and denominator have a factor that's the same except opposite. x minus y minus x. I can cross cancel that, but it makes a negative 1. So that gives me, the only thing left is negative 1 times x plus y. Or if you wanted to distribute that, it would be negative x minus y. Either one of those would be correct. All right, let's look at example 4. Here we're going to use the same principle, but then we're going to multiply or divide what's left. So again, you have to factor first before you can cross cancel. So looking at my first numerator, I can factor out a 4, and I'm left with 3x minus 5 over 5x can't be factored, so it's good to go as is. The 6 is just as it is, over 9x minus 15. I'm going to factor out a 3, and that leaves me with 3x minus 5. I can now cross cancel factors. So 3x minus 5, 3x minus 5, those cross cancel. 3 goes into 3 once, it goes into 6 2 times, and I'm left in the numerator with 4 times 2 is 8, and in the denominator 5x times 1 is 5x. So we just have 8 over 5x. Number 5 is a division. So if you'll remember, we go keep, change, flip. So before I even factor, I'm going to rewrite this as a multiplication problem. So it would be k squared minus 4 over 3k squared. That was my keep. Change to multiplication, flip to the reciprocal of the divisor. So 11k over 2 minus k. Now I'm going to factor and then cross cancel. So my numerator here is k plus 2, k minus 2 over 3k squared times 11k over 2 minus k. Now let's see where we can cross cancel. This k will cross cancel one of those. 2 minus k cross cancels k minus 2, but it makes a negative 1. They're opposites in subtraction. So the only thing left is a negative 1 times 11, so negative 11 times k plus 2, and I am not going to distribute that, just leave it as it is, all over 3k. That's the only thing left in the denominator. So we are factoring and then cross-canceling, and if it's multiplication, we are going ahead and multiplying what is left. Looking at number 6 on the next page, here we're adding or subtracting, and these are a little bit more difficult. As you might remember from regular fractions, to add or subtract, you have to have a common denominator. So in rational fractions or rational equations, or excuse me, rational expressions, the common denominator has to represent all pieces of any denominator. So in this case, my LCD, I have to have an a plus 1 and an a minus 3. And we're not going to multiply those together. What I'm going to do is I'm going to rewrite these fractions right underneath with that common denominator. A plus 1, a minus 3, a plus 1, a minus 3. And now I'm going to write what I started with in the numerator. And then this is what we do, and I'm going to do this with a different color to kind of show you what's happening here. I'm going to say, what did I do to a plus 1 to get this LCD of a plus 1 times a minus 3? I multiplied by a minus 3, so I have to do that in the numerator also. What did I do to this denominator of a minus 3 to get my LCD? I multiplied by a plus 1. So I have to do that in the numerator also. Now we are actually going to distribute so we can combine like terms and see what we have, and then put it over that common denominator. That's going to give me 3a squared minus 9a. Now we'll distribute here, plus 2a squared plus 2a all over, they have like denominators now. So I can go ahead and combine my fractions and just write that one time, a plus 1, a minus 3. Now we're not quite finished because I need to combine like terms. So 3a squared plus 5a squared, 2a squared, excuse me, 5a squared, my brain went too fast. Negative 9a plus 2a is negative 7a over a plus 1, a minus 3. Now, even though that's the final answer, we really should factor that numerator to make sure nothing's going to cross cancel in the denominator. And to do that, I would factor out an a, and I would be left with 5a minus 7 over a plus 1, a minus 3. The reason you do that is to make sure that what you end up with when you factor doesn't cross cancel with any of the pieces in the denominator. It didn't, so I'm going to go ahead and write it in its factored form. And that is the sum of these two rational expressions. So this is a little tricky. You really have to pay attention and watch for details. All right, looking at number 7, it's another one where this time we're subtracting. But in order to know what my LCD is, in this case, I have to factor my denominators so that I can see what I have. They're both short process. So here I need factors of positive 6, scoot that over so you can see it, that add up to negative 5. That's negative 3 and negative 2. So x minus 3, x minus 2. This one is factors of positive 4 that add up to negative 4, negative 2 and negative 2. So x minus 2, x minus 2. So in my LCD, and this one I'm going to show you, there's something a little tricky about this. I have to have an x minus 3. That will take care of this one. I have to have an x minus 2. That would take care of this one and one of these two. But since there are two of them in the same denominator, I have to have two of them. So let's do what we did in number 6. Let's rewrite the fractions with that common denominator, x minus 3, x minus 2, and x minus 2. You could write x minus 3 times x minus 2 squared. X minus 3, x minus 2, x minus 2. Now let's write what we already had. And now let's see what we had to multiply by to get to the common denominator. So what did I multiply this by to get me to here? I multiplied by an additional x minus 2. What did I multiply this by to get here? I multiplied by x minus 3. Now before we continue and distribute, I'm going to do one more thing. This is dangerous, this negative sign here. So I'm going to change it to addition, change the sign on the number that follows, and now I can see what's being distributed. So I'm going to distribute. That's going to give me 3x minus 6. Now because they have a common denominator, I know that everything that I write is going to be over that common denominator. So I now can go ahead and distribute that negative 2. So negative 2x, negative 2 times negative 3 is positive 6. And we end up, these two zero out, and I have 3x minus 2x is just x over that common denominator. So the hard part of this one was recognizing that you needed 2 of the x minus 2's, and that's because there were 2 of them in that one denominator. Lots to remember. All right, let's look at example 8. This is a complex fraction. It says use either method to simplify. I'm only going to use the LCD method because that's the one you absolutely have to know how to do, and it's the only one that will work for number 9. So I'm going to put each term in parentheses for number 8. I'm going to multiply by the LCD. In this case, the LCD of my two denominators, 8 and 16, is 16. So I'm going to multiply by 16 over 1. Those cross cancel. And what I have left when I distribute that 2 in the numerator, because both of my denominators cross canceled, I have 6y squared x cubed, that was a 2 times a 3, over 9y cubed x to the 4th. And now I'm just going to simplify that. 3, I can divide into each of those. These 2 y's cross cancel 2 of those, leaving that y down there. These 3 x's cross cancel 3 of those. So what do I have? I have a 2 in the numerator, and in my denominator, I have a 3yx. I'm going to write xy. Doesn't matter. So we're using the LCD. Number 9, same thing. I'm going to put that whole number, which is a p, over 1. Now I'm going to put each term in parentheses. I'm going to look at my denominators. I have a 1, a 4, a 4, and a 2p. So the LCD there is 4p. It's enough to cross cancel each one. So I write 4p over 1 if you prefer, beside each term. That's where it looks complicated. Nothing cross cancels in the first term, so that's going to give me 4p squared minus the 4's cross cancel, and I have p times p plus 2 over the 4's cross cancel, 3p minus the p's cross cancel, and 2 goes into 4 2 times, so 10. My denominator looks good, but I need to do some work on that numerator. So I'm going to go ahead and distribute that p. That's going to give me 4p squared minus p squared, negative p times positive 2 minus 2p all over 3p minus 10. That is a 3p squared, combining like terms, minus 2p over 3p minus 10. I'm now going to factor out a p in the numerator just to make sure that nothing will cross cancel. That leaves me 3p minus 2, 3p minus 10. And as you can see, nothing in the numerator will cross cancel with that denominator, but we still had to factor that to verify it. So I'm just going to write my answer as p times 3p minus 2 over 3p minus 10. I can't cross cancel those 3p's because they are parts of an entire unit. All right, next page. We have example 10. Here we're going to look at rational equations. Now those also use LCDs, but they use them in a different manner. So here it says find the domain restriction, then find the domain, find the LCD, and then solve the equation. So let's first find what x cannot be. And in order to do that, I'm going to take this denominator and I'm going to set it equal to 0. And I'm going to solve for x. And I get x cannot be 3/2. Now I'm going to take this denominator and set it equal to 0 and solve for x. And I get x cannot be 2/6, which is 1/3. So I found my domain restrictions. So the domain is the set of all x such that x is not these two numbers, negative 3/2 or 1/3. Now I need the LCD. Well, in order to get it, I'm going to have to factor this one because I can't see what all the parts are until everything is factored. And I can see my LCD has to have all of those pieces. So I need a 2, I need a 2x plus 3, and I need a 3x minus 1. Now this is where the equations are different from the expressions that we did on the prior page. So I'm going to rewrite my equation showing my second denominator in factored form. Now I'm going to put each of those terms in parentheses, and I'm going to write the LCD beside each of those. So 2 times 3x minus 1 times 2x plus 3, doesn't matter what order you put it in, 2 times 2x plus 3 times 3x minus 1, as long as you have all the parts that you showed up here. Now, let's see what happens. Get that in the picture. 2x minus 3 cross cancels 2x minus 3, so what's left here is a 2 times a 3x minus 1 times 4x minus 1. Notice no more denominator. Here, the 2's cross cancel, 3x minus 1, and what's left is 12x minus 25 and 2x plus 3. Now I don't have rational expressions any longer, so I'm just going to go ahead and multiply everything together, combine like terms, and solve for x. So let's first multiply by 2. That's going to give me 6x minus 1 times 4x minus 1. We'll finish that in a minute. Here I'm going to FOIL, so 24x squared first, plus 36x minus inside 50x minus 75. Let's FOIL this side. 24x squared minus 6x minus 4x plus 1 equals 24x squared, combine like terms, minus 14x minus 75. And I see a mistake. And I don't know if you caught it, but I see a mistake. When I distributed, this should have been a 2, so that when I got down to here, this would not have been a 4x, it would have been an 8x. I just happened to catch that. My mistake. So very easy to make these mistakes on here. All right, so let's continue. Now we're ready to combine like terms on this side. 24x squared minus 14x plus 1 equals 24x squared minus 14x minus 75. Continuing up here, I'm going to rewrite that. 24x squared minus 14x plus 1 equals 24x squared minus 14x minus 75. I can see that I have squared terms, so I want to get everything on one side equal to 0, but when I subtract this 24x squared, what you're going to see is it goes away on both sides. Then I have negative 14x plus 1 equals negative 14x minus 75. So when I add a 14x, the same thing is going to happen. And I end up with 1 equals negative 75. Well, is that ever true? Does 1 ever equal negative 75? Of course not. And so what does that tell us? After all that work, it tells us that there is no solution. But we still had to go through all that work in order to discover that. These are a lot of work. All right, so let's look at number 11. We're going to do another one just like this till you get the idea. Before I even begin, though, to fill in my right-hand blanks over here, I want to factor all of these denominators so I can see what I have. This is a short process. It's p plus 2, p plus 1. The middle one is difference of two squares, p plus 2, p minus 2. This is a short process. It's p minus 2, p plus 1. Now I can almost tell just by looking at what it is that x can't be that would cause a 0. So let's look at this first piece. Not x, but p. P cannot be a negative 2, because if it was, I would get a 0 here, and that would cause a 0 in this denominator. Looking here, p can't be a negative 1. Continuing here, p can't be negative 2, but I already have that. Here, p can't be positive 2, because that would cause a 0. Here, p can't be positive 2. I already have it. And here, p can't be negative 1. I already have it. So those are my domain restrictions, meaning my domain is the set of all p such that p is not equal to negative 2, negative 1, or 2. Now I need my LCD, and the LCD has to include all of those pieces. So I need a p plus 2. That takes care of this one and this one. I need a p plus 1. That takes care of this one and this one. And I need a p minus 2. That takes care of this one and this one. Now, in order to work this, I'm going to rewrite the equation with the denominators in their factored forms. So we've done that. Now we're going to put each term in parentheses. And this is where you are now going to use that LCD to cause all of your denominators to cross cancel. So I'm going to write it doesn't matter the order, beside each one. So it's p plus 2, p plus 1, p minus 2. You just got to squeeze it in. P plus 2, p plus 1, p minus 2, and once again here. And I know that they're all over 1, but I'm not going to show that. So here we go. P plus 2 cross cancels that. P plus 1 cross cancels that. What's left is a 5 times a p minus 2. Minus. Here, p plus 2, p minus 2. I have a 3 times a p plus 1. Here, cross cancel, and I have a 1 times a p plus 2. Distributing, let's see if I can do it correctly this time, gives me 5p minus 10. Distribute your negative 3. Negative 3p minus 3 equals p plus 2. Combining like terms, I have 2p minus 13 equals p plus 2. 2p minus 13 equals p plus 2. Let's get the p's on one side, the numbers on the other. We add a 13, and I get p equals 15. Now, before we're sure that p is allowed to be 15, you've got to look back up here at your domain restriction. Is it allowed to be 15? Yes, it is. So our solution is p equals 15. Okay, number 12. This is a literal equation, meaning it's a bunch of letters we're going to rearrange. And it says solve this formula for b. Well, we still have to use the LCD. And the LCD here, I think I'll scoot this over so you can see it. The LCD here represents each piece, so it's A, B, C. So I'm going to rewrite this so that I have a little bit more space. Put each one in parentheses, write the LCD beside it, and cross cancel. So what's left is BC equals AC plus AB. Now we're trying to solve for B, but if you notice, there are two of them. There's one here and one here. In order to solve for B, I have to get them on the same side. So I'm going to subtract an AB. That gives me BC minus AB equals AC. And this next step is the key to the whole thing. I have two of the B's that I'm looking for, and I need to get down to having just one. So in order to do that, we're going to factor out the letter that we are looking for. So B times C minus A equals AC. And now I just divide by the coefficient of B. And I get B equals AC over C minus A. All right, let's look at some application problems on the next page. The first one says to use a proportion. In fact, it says this, well, the first one, it says use a proportion to solve each problem, but we're only using a proportion to solve the first one, so those directions aren't quite right. So it says on January 6, 2010, the eventual NBA champion LA Lakers were in first place in the Western Conference of the NBA, having won 28 of their first 34 regular season games. If the team continued to win the same fraction of its games, how many games would the Lakers win for the complete 82-game season? Well, the first thing you want to do is you want to set up a guide in the margin, and we are going to set up this guide as the number 1 to the number played. So wins over played. And it's going to give us the first ratio. They won 28 out of the number that they played, which was 34. And we want to know if they continue and they play 82, so that goes on the bottom, number played, how many will they win? And so in this case, we have a proportion that we are going to use cross products with. So we end up with 34W equals 28 times 82, or 34W equals 2,296. Divide both sides by 34, and I get that the number of wins is about 67.529, so approximately 68. So they will have approximately 68 wins, and we solved that using a proportion and cross products. Okay, number 14, this is one of those distance, rate, and time problems. It says Casey can travel 8 miles upstream in the same time it takes her to go 12 miles downstream. Her boat goes 15 miles per hour in still water. What is the rate of the current? We are going to let C equal the rate of the current. It's what we don't know. Now, the way that you were taught to do these is to set up a chart or a table that looks like this. We have upstream, we have downstream, we have the distance equal to the rate times the time. And we're going to fill in each of those cells. So it says she goes 8 miles upstream, that's her distance. She goes 12 miles downstream. Her boat goes 15 miles in still water, meaning just the boat without any current. Well, when you are going upstream, you're going against the current. So it's your boat minus the rate of the current. It's slowing you down. When you're going downstream, that current is pushing you. So you've got your boat's rate plus whatever that current is. Now, we also know that distance equals rate times time. So if I want to solve it for time, I divide both sides by R. So the time cells are going to be, for upstream, it's going to be its distance divided by its rate. So distance over rate, just like it says right here. The downstream is its distance over its rate. And the other thing that we are told is that the times going upstream and downstream are the same. They are equal. So I'm going to say that 8 over 15 minus C, that's the upstream time, is equal to 12 over 15 plus C, that's the downstream time. Put those in parentheses. And once again, we're going to use cross products. So 8 times 15 plus C equals 12 times 15 minus C. And now we're just going to distribute and solve for C. So 8 times 15, 120, plus 8C equals 12 times 15, 180, minus 12C. Let's add a 12c to both sides. That's supposed to be a 12, sorry. And I end up with 120 plus 20c equals 180. Subtract the 120, and we get 20c equals 60. Divide by 20, and we get that the current is going 3 miles per hour. But you have to do that by setting up that chart. All right, let's look at another kind of chart. This is a work rate problem. It says, Mrs. Disher is a high school mathematics teacher, and we're going to use a D for her. I'm just going to write that up there rather than a let statement. She can grade a set of chapter tests in 5 hours working alone. If her student teacher, Mr. Howells, we'll call him H, helps her, it will take 3 hours to grade the test. In other words, working together. How long would it take him if he worked alone? So once again, we're going to set up a chart. This one's a little bit different. Here I have Mrs. Disher, Mr. Howells. This is their hourly rate. This is the time it takes them working together. And this is the fraction of the job done by each one. Now, alone, it takes her 5 hours. So in 1 hour, she has 1/5 done. Alone, we don't know how long it takes him, so we're going to say, let X equal H's time alone. So in 1 hour, it would be 1/X, and that's kind of the key to this problem. Their time together, we know, it tells us, is 3. The fraction done is these two multiplied together. So 1/5 times 3 is 3/5. 1x times 3 is 3/x. And I know that the fraction that she contributes plus the fraction that he contributes equals 1 whole job done. That's how work rates work. It's always going to be equal to 1 unless you have some different kind of situation. Now I need to clear the denominators. My LCD is a 5x. So I'm going to put each term in parentheses, write the LCD beside it, cross cancel. I'm left with 3x, 3 times 5, plus 15 equals 5x. And now we just have to solve for x, which was his time. So let's bring it up here. 15 equals 2x, divide by 2, and it takes him 7.5 hours. So 7.5 hours for Mr. H if he's working alone. All right, the last type of application problem are called variation problems. And we're going to look at 2 of them. One is a direct variation and one is an inverse variation. And they all work the same way. So it says, for a body falling freely from rest, the distance the body falls. So before I even go any further, I'm going to say let d equal distance, because that's one of the things we're talking about, varies directly as the square of the time. T equal time. Step 1 is to write a variation equation. So this is my first step. So go back to the words and translate. The distance varies directly equals k. Directly means multiply times the square of the time, t squared. Our second step is to find k. And I do that by taking our variation equation and putting in the initial values. So if an object is dropped from the top of a tower this high, so that's the distance, it hits the ground in 6 seconds. We're going to solve for k. So 576 equals 36k, divide by 36, and I get k equals, use your calculator, 576 divided by 36, and you will see that k is 16. Now, what we're going to do is we're going to bring this up and this equation over, and I'm going to write that again. D equals, but instead of K, I'm going to write what we found. 16 times T squared. The next step is to put in the last number, and it says how far did it fall in the first 4 seconds. Well, if it fell 576 feet in 6 seconds, then our number in 4 seconds should be smaller, right? So the 4 is time, so it goes right there. Following order of operations, you have to square first. So 16 times 16, or the distance is 256 feet. So distance is 256 feet in 4 seconds. Now I want to do this second one so you see it's the same exact process, just that this time it's inverse. So when it's direct it means multiply, inverse means divide. So it says the frequency of a vibrating string, let's call that F, varies inversely as its length. We'll call that L. So the frequency varies inversely equals K divided by the length. It still has a K in it, and that's our next step, is to find the K. So we're going to put in the initial values. F equals K divided by L. It says, suppose a piano string 2 feet long, so that's the length, vibrates 250 cycles per second. So 250 equals K over 2. To get rid of that fraction, I multiply both sides by 2, and I get K equals 500. So I found the first thing that I needed. I bring this up, I bring this over, I write it again, but I use the K that we found. And now I fill in the next piece. What frequency would a string 5 feet long have? So F equals 500 divided by 5, where the frequency would be 100 cycles per second. So frequency is 100 cycles per second. Same exact process.